93 million miles away, something just broke loose on the surface of the sun. A magnetic loop the size of a dozen Earths twisted too far, snapped, and hurled a cloud of charged gas weighing billions of tons out into space, aimed this time at us. You can't see it. You can't feel it. There was no alarm on your phone, no crack of thunder, no warning of any kind. But the satellites built to stare at the sun caught the flash the instant it happened, and the scientists reading those instruments went very quiet. Because here's the part nobody is telling you. The thing that just left the sun is probably not the dangerous one. It's the warning shot. And the sun is now in the most violent stretch of its 11-year cycle, which means the real one, the big one, is a question of when, not if. So here is the question this entire video is built around, and I want you to hold on to it. When it hits, would you survive the day it arrives? Not would humanity survive. You, your city, your week, your refrigerator, your phone, the pump at your gas station, the lights in your hospital. Hold that question, because the answer is the last thing you'll hear in this video. And by the time we get there, you'll understand why this exact moment in history is more dangerous than any solar storm your grandparents ever lived through, even though the sun itself hasn't changed at all. Stay with me. We're going to walk through this one step at a time, and every single step gets closer to you. Let's start with the thing that already happened. The flash you completely missed. The sun didn't just glow brighter, it fired a coronal mass ejection, a cloud of charged particles weighing billions of tons launched into space at over 1 million miles per hour. People mix up two things here, so let me make it simple. The solar flare is the flash of light, the muzzle blast. The coronal mass ejection is the cannonball behind it, an actual chunk of the sun's outer atmosphere blown off the star by magnetic fields that build up tension like an overstretched rubber band and then snap. When one of those loops lets go, it releases more energy in a few minutes than all of human civilization uses in an entire year. And when it's aimed straight at Earth, here's the number that should stop you. The most powerful storm ever recorded, back in 1859, crossed the entire 93 million mile gap between the sun and Earth in just 17.5 hours. Not days, hours. But a cloud of particles in empty space can't hurt you. Not yet. What turns it into a weapon is the instant it slams into the invisible thing wrapped around our planet. And the first crack in that shield shows up in a place you'd never expect. Earth has a force field, a real one, not science fiction, and a strong enough solar storm can punch a dent in it deep enough to expose what's underneath. That shield is the magnetosphere, the magnetic bubble generated by the churning molten iron at the center of our planet. It deflects most of what the sun throws at us, and without it, life on the surface simply would not exist. Picture it as an invisible dome over your whole sky right now, silent, doing its job, completely taken for granted. When a coronal mass ejection hits, that dome compresses, shudders, and rings like a struck bell, and a geomagnetic storm begins. Most of the time, the shield holds, and all you get is a beautiful aurora. But it's thinnest at the poles, and there's one region over the South Atlantic where it's permanently weak, a kind of permanent dent, and that's where the damage gets through first. And here's the part that should unsettle you. The very first casualties aren't on the ground. They're a few hundred miles over your head, and the first time a storm caught one company off guard up there, it cost them tens of millions of dollars in a matter of days. That company launched 49 brand new satellites in February 2022 and lost 38 of them within days. They fell out of the sky before they ever reached their working orbit. And here's the detail that should frighten you. That storm was a minor one. Not severe, not historic, minor. Here's how a mild storm destroys nearly 40 satellites at once. When a solar storm dumps its energy into the upper atmosphere, that atmosphere heats up and physically swells, puffing outward and reaching higher into space than normal. Satellites that were gliding through near vacuum suddenly hit air thick enough to drag on them, and they slow, spiral, and burn up. The ones high enough to survive the drag face a second killer. Charged particles that fry their circuits, scramble their memory, and blind their sensors. We now lean on thousands of these machines for internet, weather forecasting, banking, television, and the maps in your pocket. But satellites, at least, are replaceable. You build more and launch them again. And here's where the tone of this whole story changes. Everything you've heard so far is inconvenient. Lost machines, scrambled signals. From here on, it stops being an inconvenience and starts being the kind of thing that gets people hurt. The next effect has already forced pilots, mid-flight, to turn their planes completely around. During a severe solar storm, entire regions can go radio silent, and pilots flying over the top of the world have been forced to reroute thousands of miles just to stay in contact with the ground. Here's why. High-frequency radio, the long-distance kind that aviation, shipping, the military, and emergency services all depend on, works by bouncing signals off a layer of the atmosphere called the ionosphere, like skipping a stone off the surface of a lake. A solar storm supercharges that layer and turns the smooth lake into chaos. And the signal that used to bounce now scatters into useless static. That's why air traffic corridors over the Arctic shut down completely during big storms. The planes physically cannot talk to anyone up there, so they're not allowed to fly the route at all. And remember the question I asked you at the start, would you survive the day the big one hits? We're still several steps from the answer, but watch how fast this has stopped being about the sky. Because if the voices in the air can be scrambled, so can the invisible signal that quietly tells 3 billion people where they are. Imagine it's an ordinary morning. You glance at the map on your phone to find a route, and it swears you're a block from where you're actually standing. A solar storm can throw your GPS off by hundreds of feet, and during the worst of it, switch it off entirely. GPS feels like magic, but it's really just timing. A handful of satellites broadcasting the time stamped to the billionth of a second, and your phone doing the math on how long each signal took to arrive. A storm distorts the atmosphere those signals cross, bending and delaying them. And suddenly, the math is wrong. In your car, that's a shrug. But the same signal quietly runs aircraft on final approach to a runway, container ships threading a harbor, ambulances being routed to a heart attack, and even the precise timestamps that keep stock markets and power grids synchronized. In May 2024, during the strongest geomagnetic storm in 20 years, it hit farmers in the middle of planting season, freezing the GPS-guided tractors they rely on to seed entire fields. And here's the thing about everything I've shown you up to this point. GPS, radio, satellites, every one of them comes back the moment the storm passes. They reset. The next one doesn't. The next one is the effect that can stay broken for months. And it's the one I told you to wait for. A severe solar storm can melt the giant transformers at the heart of the power grid, the building-sized machines that take more than a year to manufacture and replace. So picture that same ordinary morning, but the grid is gone. You reach for the light switch. Nothing. The fridge is dark, and your food is already turning. The gas station can't pump because the pumps run on electricity. The store can't take your card. The tap slows to a trickle because the water pressure needed power too. not for an afternoon, for weeks. Here's the chain of events, and it's terrifyingly simple. When the magnetosphere shakes, it induces enormous electrical currents in long metal conductors, and nothing on Earth is longer or more metal than the grid's transmission lines, stretching unbroken for thousands of miles. Those currents pour into transformers built only for ordinary current, and they overheat until the copper inside literally cooks itself. This is not theoretical. On March 13, 1989, a solar storm collapsed the entire Hydro-Quebec power grid in 90 seconds flat. 6 million people lost power in the dead of a Canadian winter for 9 hours, and many for days. And that storm was only about half as strong as the Carrington event of 1859. The true nightmare isn't the blackout. It's that it can't be fixed quickly because those giant transformers aren't sitting on a shelf. Each one is custom built to order. This is the clearest piece of the answer to our question. Surviving the day a storm hits is one thing. Surviving the months that follow with no grid is something else entirely. And while the grid is the danger on the ground, there's a small group of people for whom a solar storm is an immediate, physical threat to their own bodies. And history came within a few weeks of killing some of the most famous men alive. A strong enough solar storm could hit anyone at high altitude over the poles with a dangerous dose of radiation. And to astronauts caught in the open, it could be lethal. Down here on the surface, the atmosphere and magnetosphere soak it up before it reaches you. But climb to 40,000 feet over the Arctic, where the protection is thin, and passengers on a polar flight absorb a measurable spike in radiation during a major storm. The other reason airlines turn those flights around. For astronauts outside the shield entirely, a major event is one of the very few things in space that could kill a crew outright. And the history here is chilling. In August 1972, a colossal solar storm erupted, and it struck in the narrow gap between two crewed moon missions, Apollo 16 and Apollo 17. If astronauts had been on the lunar surface or crossing open space when it hit, the radiation could have made them gravely ill, or worse. The program never knew how close it came. We're now one step from the answer to the question you've been holding since the very beginning. But before I give it to you, there's one last effect. The one that turns this entire story from a documentary about space into a number with your name on it. Scientists estimate that a worst-case solar storm striking the modern world could cause damage on the order of $2 trillion in the United States alone, with some insurance risk models running as high as $2.6 trillion. That would make it one of the single most expensive disasters our civilization has ever faced. Just added up fried satellites, a grid down for months, halted shipping and grounded aviation, frozen banking, spoiled food and medicine, and the slow agony of rebuilding custom transformers one at a time while millions wait. Recovery from a true Carrington-class event has been estimated to take anywhere from a couple of weeks at the best end to 1 or 2 full years at the worst. And here's the quietest, cruelest part. You'd pay for all of it whether or not your own lights ever so much as flickered, in higher prices, lost wages, broken supply chains, and the taxes that fund the rebuild. The storm that began as an invisible flash on the sun finishes its journey, like every disaster eventually does, inside your monthly budget. So that finally brings us to the answer. And I'll be honest with you. Everything you've heard so far points to one uncomfortable conclusion. But it is not the conclusion most people expect. And it flips the entire question you came here with on its head. So, would you survive the day the big one hits? Here's the honest answer. Yes. Almost certainly, you'd survive the day itself. People always have. The sun has been firing these storms at Earth for billions of years, long before we showed up to notice. The Carrington event of 1859, still the most powerful storm in recorded history, set telegraph offices on fire, gave operators electric shocks, and lit auroras so bright that people woke up thinking it was dawn. And humanity barely blinked. Because in 1859, there was almost nothing electrical for the storm to break. But that's not the twist. The twist is this. The solar storm was never really the threat. The sun hasn't changed at all. It's doing the exact same thing it has always done, riding its 11-year rhythm of calm and fury. And right now, it sits at the violent peak of that cycle. The danger didn't grow on the sun's side. It grew on ours. A Carrington-level storm in 1859 burned a few telegraph wires. The identical storm today lands on a civilization that has quietly wired its entire existence. Your money, your food, your water, your medicine, every conversation you have at a distance, into a delicate web of electronics the sun can reach out and switch off in an afternoon. The storm didn't get more dangerous. We did. We built a world the sun can unplug, and then we forgot the sun was even there. And that recontextualizes the whole question. You came here asking, would I survive a solar storm? And the answer is yes, you would. But the real question, the one hiding underneath, is far more uncomfortable, and it loops straight back to that flash we started with. Because that flash, the warning shot, is sometimes all the warning we get. The big one, when it comes, could cross the entire distance from the sun in well under a day. And we still have not hardened the grid your whole life depends on against it. We know it's coming. We don't know if it's next year or in 50. We've simply never, in all of human history, been more exposed to it than we are right now tonight, with the sun at its loudest. So that invisible flash, the one that left the sun before you ever knew it happened, the warning shot the scientists are watching so closely, was never really the story. The story is that we spent a single century building a civilization that runs entirely on the one thing a star can erase in an afternoon, and then stopped looking up. And the strangest thought to leave you with is this. Somewhere on the surface of the sun right now, a magnetic loop is already twisting itself into the shape of the next big one. It will snap. It always does. The only thing left to find out is whether anyone is ready when it does, and whether you'll get any more warning than the flash that nobody felt. If you want to keep learning how the universe could end you, and whether you'd survive it, subscribe and stay with us. Because there's a lot more out there with your name on it, quietly right now. And drop your country in the comments. Then tell me honestly, do you think your power grid is ready for this?